Hi, this is the problem I saw on the Wyzant site. It's a basic equilibrium problem, and we have reactant A is being changed into reactant B, and it's a reversible reaction. And we're told when equilibrium's reached that the concentration constant for our equilibrium is 3.25. Now, the expression for the equilibrium constant is written the concentration of the products over the reactants, and they're raised to the power of their coefficients. I wrote the expression over here on the right on the top for cases C, and we have product B. Since the coefficient of B was 1, it's raised to the first power being divided by the concentration of reactant A. Once again, its coefficient's 1, so it's raised to the first power. If you look to the table on the lower left, we're going to make an assumption that we start out with just 1 mole per liter. That's our molar concentration of reactant A. And before the reaction starts, there's 0 of B. So initially we have 1 for A, 0 for B. Now, how much does it change? I don't have a clue. And when you don't have a clue in science, you use X. So I know that X amount of A changed into B. So the change for A would be minus X, and the change for B would be plus X. Then we would know at equilibrium, the concentration of A would be 1 minus X, and the concentration of B would be X. We plug that into our expression. We know that case of C is given at 3.25, and we solve for X, which is called the molar solubility. So just put 3.25 equal to X over 1 minus X. Multiply both sides, clear the denominator. Then we'd get 3.25 minus 3.25X equals X. Do a little bit of algebra, get all the X's on one side, divide by the coefficient of X, and then you get X is equal to 3.25 being divided by 4.25. So our molar solubility is 0.75. So you know at equilibrium, your concentration of your reactant A would be 1 minus that molar solubility, and that would be equal to 0.235 molarity, and the molar solubility is the concentration of B, 0.765. Now, I want to take you over to board 2, and just to show you how the expression for the equilibrium constant is written for a little more complex reaction. And this, we have 2 reactants, A and B, and we have a balanced equation for a reversible reaction when 3 moles of A2 plus 1 mole of B2 is being changed into 2 moles of a compound called Ba3. To write that expression for the equilibrium constant, you take the concentrations of the products raised to the power of their coefficient divided by the product of the concentration of the reactants raised to the power of their coefficients. So you see that since I had a coefficient of 2 for my product, I have in my numerator brace, once again, brace means molarity, the concentration of my product being squared divided by my products A, who has a coefficient of 3, being raised to the third power, times B raised to the first power. Hope you enjoyed this video. I like making it for you. Have a good day.